Good evening. I'm Spot On Weather meteorologist Matthew Euler, and as promised, I'm going to take a look tonight at the final winter outlook update for the 2019-2020 winter season. This image showing you around the Norfolk area of some snow. This is right down around City Hall Avenue, a very cold, wintry day in this particular picture, and from a past winter storm. So I'm going to first start things off by talking about the weighted winter forecast update factors. These really have not changed from my initial September winter forecast. And these are the main weighted factors I'm utilizing in my final winter outlook here in my update. And I'll show you each of these as I progress through these slides tonight. The first one is the warmer than normal sea surface temperature anomalies in the Northeast Pacific Ocean. And in that case, that's going to favor a more of a persistent downstream eastern trough in the U.S. and more of a western U.S. ridge pattern. So that continues. And I've been waiting since September. I've been following those sea surface temperature anomalies, and I'll show you that here in a minute. We'll talk a little bit more about that. Second is the low solar activity. And I've read some blogs and I've read some articles out there on this. We've done some research on the low solar activity, and really low solar activity doesn't necessarily mean that just straight up that it's going to be a colder winter. It just generally leads to greater high latitude blocking episodes, as well as more of a negative Arctic oscillation, a negative North Atlantic oscillation. And so in low solar activity years, I'm going to show you a little bit of research that I did find in tonight's video. The third weighted factor remains the predominant influence this winter, which we really believe here at Spot On Weather is going to come more from the Arctic, from the higher latitudes, vice the Pacific Ocean, which that occurred last year. We had quite a strong Pacific jet stream last year. And the reason we're going with more of an Arctic influence this year for the weather across the Mid-Atlantic and Virginia is due to ENSO neutral conditions. We really don't foresee a El Nino or a La Nina winter. We're kind of like in between in the neutral phase. So we don't really see a very strong Pacific signal. Fourthly, we're going to take a look at the propensity for a predominant negative Arctic oscillation, North Atlantic oscillation. I'll show you the trends from the past earlier this year and what we're currently trending as we head into the latter stages of November. And then finally, the accumulated cyclone energy values. We take that into account every season in producing, or every year in producing the winter outlook. So the first thing I want to talk about is the sea surface temperature anomalies. You see that reddish shading there with the dark circle, the outlined circle around it there in the Northeast Pacific Ocean into the Gulf of Alaska. And this was as of the 13th of November. And I've been following this closely because last fall, we saw this signature across the Northeast Pacific waters of a warmer than normal sea surface temperatures. And over time, throughout the course of last fall, as well as into early winter, that area had actually cooled off last winter. We don't see that this year. This area of above normal sea surface temperatures in the Northeast Pacific plays a significant role in the type of jet stream configuration we typically see. And we haven't seen many changes to this area for the sea surface temperatures. We'll keep looking and keep checking this out. But right now, based on past history, this would signify more of a western ridge over the U.S. and an eastern trough. And with those ridges, you typically have warmer than normal temperatures, and with the trough, you get colder than normal temperatures. Let's take a look at the comparison to 2014. The image on the left shows what it looked like in September 2019, this September, as compared to September 2014. Now, if you were to Google the blob, BLOB, you would find some really interesting articles about the anomalously warm sea surface temperatures in the Northeast Pacific, especially applicable to the 2014-15 season, wintertime. You can look at the September 2014 and September 2019, and you can really see a really good striking similarity. These are similar looking departures to 2014. The image on the right shows what happened as far as the observed temperature anomalies. Blue shading indicating colder than normal conditions, and the red and the magenta colors and that gray color, those all indicate above normal air temperatures. So you can see what happened here. We had more of a ridge in the western United States up into Alaska with that type of anomalously warm sea surface temperatures in the Northeast Pacific back in 2014. We had a much warmer and drier winter across the western U.S., and we had a much cooler and more unsettled weather pattern across the eastern U.S. And this is one of the big factors you have to look at, especially when it comes to winter outlooks. Ridge in the west, trough in the east. If that's the predominant story for a winter season, the months of December, January, and February, that usually leads to colder than normal temperatures across the eastern U.S., warmer and drier conditions across the western U.S. And, I was out in San Diego at this particular point in time, and, I could just remember the rain gauge out there just remained dry and dry and dry. We didn't get hardly any rain that winter across San Diego out in Southern California. I just collected some bugs, basically, but that was about it. So this is something we have to really look out for. That winter had the ridiculously resilient ridge, triple R, out west, which this pattern just never seemed to change. Next factor, weighted factor again, just rehashing kind of like what I went over in September, my winter outlook, is a low solar activity. The image on the left shows a special picture of the sun. And you'll notice there's no dark splotches, no dark spots on this particular image of the sun. And that is mainly due to the fact that our daily sunspot numbers have dramatically dropped. The image on the graphic on the right shows the weakening trend in the solar cycles, basically since solar cycle 21. You look at solar cycle 21 where it peaked, then you look at solar cycle 22 where it peaked, solar cycle 23, and then solar cycle 24. We're about to enter solar cycle 25. And you can get some really cool updates on these type of graphics and sunspot numbers from the Space Weather Center. NOAA has a Space Weather Center. The Air Force also has some cool stuff. So check it out for yourself. But we are having a very low solar activity period going on right now. Now, why is low solar activity important? Okay, this has to do with increased frequency of what's known as high latitude blocking. Now, this research was done by meteorologist Paul Dorian from Perspecta Inc. And I just wanted to share some of the research that Paul Dorian had gathered. High latitude blocking, the first bullet there, high latitude blocking during the winter season is characterized by persistent high pressure in northern latitude areas such as Greenland, northeastern Canada, and Iceland. And then if you go back and look back at those years with low solar activity, the upper level geopotential height anomaly pattern is dominated by high pressure over these high latitude regions during the winter season, the months of December, January, and February. Without this type of blocking pattern in the upper atmosphere, it is more difficult to get sustained cold air masses in the eastern U.S. during the winter season. So in this case, with high latitude blocking into parts of Greenland, the far northern latitudes, northeastern Canada, and Iceland, we are looking at a jet stream configuration where we have troughs coming down, a trough or a kink or a dip in the jet stream across the eastern United States. And that usually when you have warmer air at higher latitudes, it typically dislodges much colder air south into the United States or parts of Europe or parts of Asia. So this is real interesting stuff. The second bullet there says, in addition to the increased chance of sustained cold air during low solar activity years, that high latitude blocking in the upper atmosphere tends to slow down the movement and departure of storms along the mid-Atlantic northeast U.S. coastlines, and this too increases the chances for significant snowfall as long as there is entrenched cold air in place. In fact, some of the greatest snowstorms in the mid-Atlantic northeastern U.S. regions took place during low solar activity winters. And here's a couple from the past: February 2010, December 2009, and January 1996 are three of the months and three of the different years in which we had low solar activity and we had increased frequency of high latitude blocking in the North Atlantic. Now, we talk about Arctic oscillation and North Atlantic oscillation. We talk about that North Atlantic oscillation when we have high latitude blocking in the warmer air and higher latitudes. Get that strong block or upper ridge going into Greenland. That usually leads to a buckle in the jet stream across the eastern U.S. and increasing the chances for cold air, more frequent cold air outbreaks, as well as if we get a nor'easter or east coast winter storm, what happens is that upper level ridge or those upper level higher pressure, that does not allow the storm. Basically, a nor'easter or an east coast storm is not going to readily be able to escape out to sea when you get that high latitude blocking out over the North Atlantic. Low pressure systems tend to seek areas with lower atmospheric pressure. They want to take the path of least resistance. So areas of low pressure, they avoid areas of upper level ridges and high pressure. So in other words, the storm systems don't readily escape out to sea and you get more significant impacts of nor'easters or east coast winter storms when we have a lot of high latitude blocking episodes. So this low solar activity is very important as far as setting up that North Atlantic oscillation. The North Atlantic oscillation is negative. We get this huge ridge up into Greenland. All right, next I'm going to talk about the Arctic primary influence this winter. We really believe it's spot on weather. We have ENSO-neutral conditions. They're going to persist through the winter months, December through February. That's going to result in significantly weakening the Pacific influence on the weather across the United States. Of course, in the mid-latitudes, all weather moves from west to east. So what happens in the Pacific is very important to our weather, especially during the winter months. Now, in this case with ENSO-neutral conditions, we don't have a very strong signal from the Pacific this winter. All right, so what we're expecting is more of Arctic influence, Arctic driving influence this winter, with a negative Arctic oscillation being the primary driver of temperatures. The combination of the positive or warmer than normal sea surface temperature anomalies across the Northeast Pacific, as I showed, and that negative tendency of the Arctic oscillation is going to result in more of a trough across the eastern United States, colder than normal temperatures, and that ridge and warmer than normal temperatures across the western U.S. for the majority of the winter. Now, will there always be a negative Arctic oscillation? No. Definitely not going to say that, because we are going to have some cases where the Arctic oscillation will go positive and we will see a warm-up. There'll be milder periods in between these colder outbreaks. So I'm not expecting wall-to-wall or from December 1st to February 28th, I'm not expecting just cold air to dominate the entire winter. We are going to have those breaks, which we typically get, especially for those that live in southeastern Virginia, because you have the influence of the nearby Atlantic Ocean. And anytime you live on a coastline with a major ocean, you do have some modifying effects of that ocean upon the air mass. So this is what we're thinking is going to be the main driver this winter. Now let's take a look at the latest model predictions for the ENSO, the El Nino Southern Oscillation. These are run by the Climate Prediction Center. And if you look at all the lines, all the different lines represent the model runs, the climate models. And generally what we're looking at is majority of the model runs, the majority of those lines are clustered between 0 and 0.5 degrees Celsius above normal in the El Nino 3.4 region. What does this mean? We have ENSO-neutral conditions whenever we have the water temperatures in the eastern equatorial Pacific, in that Nino 3.4 region between negative 0.5 and positive 0.5 Celsius. These are your temperature anomalies. What we're looking at is a majority of models are indicating 0.3 to 0.5 degrees Celsius departure from normal in the Nino 3.4 region, which would equate to a ENSO-neutral winter. Now, if by chance those sea surface temperature anomalies were to warm above 0.5 degrees Celsius, then we would be talking possibly about a weak El Nino. But right now, the models have been fairly consistent. I've been keeping an eye on this since I made the first winter outlook back in September, that video. and they all are sticking to the same solution. Now let's look at the Arctic Oscillation and North Atlantic Oscillation, the latest trends. I want you to I really believe the low solar is playing into this, the low solar activity. Take a look. The image on the left is the Arctic Oscillation. The image on the right is the North Atlantic Oscillation, or the NAO. And look at how negative the AO and the NAO have been. We're going all the way back to early August. There have been some episodes where it has swung back to the positive side, but we're mainly looking at a negative AO and a negative NAO. So really impressive tendency, trend for this to remain negative. And then finally, I want to talk about accumulated cyclone energy, the ACE update. And if you recall from my September video, I mentioned that I needed to keep a close eye on this. Hurricane season runs through November 30th. And look at the North Atlantic ACE. It ended up right now, as of, let's see, this would have been as of November 13, 2019, the ACE was at 124.1, while the average climatological ACE is at 101.1. So in the North Atlantic Basin, we are slightly above normal for the ACE values. Doesn't really look like the Atlantic's going to come to life between now and November 30th. We still have just under 2 weeks, or just about 2 weeks left in the hurricane season in the Atlantic Basin. But overall, we're looking at a lower than normal, or a slightly above normal ACE value in the Atlantic Basin. All right, now let's get to my final slide here. I did post this last night in social media. This is my final winter outlook for December, January, and February. This winter is going to be primarily influenced by a negative Arctic oscillation. Like I said, that Arctic oscillation is not going to remain negative the entire winter. It's going to have its occasional positive modes. But for the most part, the majority of the winter, we're looking at a primarily negative Arctic oscillation, resulting in that trough and the colder than normal temperatures across the eastern United States. And then we'll have a ridge or warmer than normal and drier conditions out in the western U.S. Now, the Pacific teleconnections will be less influential this winter. And we're believing that because of the El Nino Southern Oscillation, the ENSO neutral conditions. We're still going to need to watch the Madden-Julian Oscillation, the MJO, closely for possible offsetting effects. This is very possible. The MJO has really thrown a wrench in the forecasts of the past. It really has. When it goes stronger into the warmer phases, sometimes it can actually trump that negative Arctic oscillation, and we get more of a Pacific air mass influence from west coast to east coast, and a more zonal jet stream, more west to east flow. So we still have to keep a close eye on the Madden-Julian Oscillation, the MJO, for the upcoming winter. There will be a primary trough in the eastern U.S. and a ridge in the western U.S. And another factor is that above normal sea surface temperature anomalies in the Northeast Pacific Ocean. This is going to direct colder than normal temperatures into the eastern U.S. with above normal temperatures across the west. Now look at this again. Look at that. Look at that circled area there in the Northeast Pacific and in the Gulf of Alaska, above normal. All right? And this is departures are in degrees Celsius, by the way. So we have above normal water. It's clearly evident on this latest sea surface temperature anomaly map. So that's what we believe. That's what's happened in the past. Colder than normal east, warmer than normal west. Now, we will see those occasional mild spells in between the cold periods. Again, this winter is not going to be wall-to-wall cold, but we are looking at more cold and warmth overall during the course of the winter season. The ACE values are slightly higher than normal, as I mentioned, for the North Atlantic Ocean Basin. We still believe, though, that there is a lot of potential energy lingering over the ocean basin for nor'easter development. So we're still going to see our fair share of nor'easters, those East Coast winter storms. We're not talking about a large disparity in the ACE values from what it is compared to normal. Now, the wild card for me, this is really interesting. This is going to be, and I've already read some blogs, Dr. Judah Cohen, check them out, AER, Atmospheric Environmental Research. All right, we've already started to see some propagation of energy from the troposphere to the stratosphere that's already attempting to weaken the polar vortex. Now you got to realize something. The polar vortex is a large, swirling, counterclockwise airflow that typically sets up. It's a circulation over the polar areas in the winter. Recently, with the high latitude blocking patterns that we've seen, one on the Pacific side and one on the Atlantic side, it's actually resulted in a slight weakening of the polar vortex already. So we could see a polar vortex displacement or even a polar vortex split. We had that split last winter in late, actually into December. I believe it was late December and early January. And then the resultant weather. Now, when you get a polar vortex split, all right, it may take 3 weeks between the split and you actually feeling the effects of that split. So last year, I believe it was by around New Year's, we saw that polar vortex split. It took until late January, like the last 10 days of January, for that split to actually impact the weather in the troposphere where we live. And that resulted in bitterly cold air that came down from Canada. But right now, there's indications, even some of the longer range models are showing a polar vortex disruption or a split. So we got to keep an eye on this, because if this occurs, this could result in much below normal temperatures in the eastern U.S. This will need to be watched closely in the coming weeks, as some models are already indicating that weakening state to the vortex. Again, that's kind of like one of those wild cards. We could see much below normal temperatures, vice just below normal temperatures. Okay. Now, this is my overall assessment. This is our final winter assessment, winter outlook assessment. We're expecting below normal temperatures. We're looking on the order of 1 to 3 degrees Fahrenheit below normal overall for the course of the winter. Now, remember, my outlook starts 1 December and ends 28 February, at the end of February. So over that, basically that 90-day period or so, we're looking at below normal temperatures on the order of 1 to 3 degrees Fahrenheit, and then near normal precipitation, including near normal snowfall for Hampton Road cities in southeast Virginia. Hampton Road cities typically average around 7 inches of snow in a winter. It's not a whole lot here. We get a lot of influence of the Atlantic Ocean, and that basically, in a lot of cases, you get the strong wind flow off the Atlantic Ocean. It modifies the air mass enough to keep most precipitation in liquid form. But we still are expecting near normal snowfall in the area. Now, we're expecting the majority of that snowfall to occur in January and February. And, I've seen this in past winters in southeast Virginia here. Sometimes you get these big, huge snowstorms where you might lay down 6 to 7 inches of snow. And in one snowstorm, you already hit your normal for the winter season. So that's something I got to keep an eye on too. Could we get little clipper systems coming down where we get maybe 2 to 4 inch snows in a couple different events, or are we going to get a major event where we exceed the 7-inch normal? But right now, it's looking like near normal snowfall for Hampton Road cities, but below normal temperatures. So we are expecting a cooler than normal winter. So get ready for that. Okay, that wraps things up at Spot on Weather. Thank you for listening. Thank you for subscribing. I do greatly appreciate your support. We're at 188 subscribers. I thank you so much for subscribing to my channel. We're just 12 shy of the 200 mark. So feel free to get the word out and spread the channel out and let your friends know about us. We greatly appreciate it again. We love the weather. We love sharing the weather with you. Take care, everybody. We're Spot on Weather. If we're not spot on, we're not doing it right. Continue to follow me on Facebook and Twitter as I do my updates for the forecasts, as well as I try to put out some good little blogs every once in a while, and so you'll see it there. All right, that wraps things up. Have a great evening, everybody. Take care, and God bless everybody.